The routing intent feature in Virtual WAN has been generally available for about 6 months now, so I thought it might be nice to make a video and share some of the learnings on the feature. It's definitely one of the most popular features that's been used by customers because it offers a one-click easy button for inter-region routing via firewalls, which is what a lot of customers want, just a simple basic any-to-any through a firewall mesh. As you can see here, this is a page which you might want to bookmark. It's the What's New page in Virtual WAN. The routing intent feature went GA in 2023. So just a baseline here on what routing intent gave us in terms of its core value. Well, here's a basic multi-region network, 2 virtual WAN hubs inside a common virtual WAN, 2 spokes, a couple of branches. Prior to Virtual WAN, if you wanted to do a data path, which most customers require, which is traffic from spoke in one region, traffic to the spoke in the other region, I want to go through the firewall, across my hub-to-hub connection, through the other firewall, and down to this spoke. That wasn't possible before routing intent. So this was a big gap with Virtual WAN, which stopped a lot of customers adopting it or having to use other workarounds such as tiered VNets or complicated custom routing config or firing it via express route rather than hub to hub. But routing intent unlocked this flow, and a lot of customers have adopted the feature. It also gave us the ability to use some NVAs inside of Virtual WAN for east-west firewalling from the likes of Fortinet, Checkpoint, Palo Alto, as well as the native Azure firewall, so there's some flexibility there. And finally, what it also gave us is if we have a branch connected in, whether it's ExpressRoute, site-to-site VPN, point-to-site VPN, previously branch-to-branch traffic, which is a flow enabled by Virtual WAN, couldn't be firewalled. But with routing intent, you can firewall that traffic. So traffic coming in from, say, your P2S users, coming into Azure, goes through the firewall before it goes back down to maybe your ExpressRoute connected branch. So those are the 3 main core value propositions of routing intent, all very popular use cases, hence the adoption. And I think if you want to get a very concise but much more impactful overview of what routing intent gives you, check out this video by Jose Marino. I've previously shared it on YouTube, but I'll include the link in the description below. One of the learnings that I want to share, and one of the advanced topologies that you might want to have in your toolkit as a network engineer working on Azure, is in the area of combining custom routing and routing intent. Because if you've seen some of the previous videos, one of the things that Virtual WAN gives you is the ability to use custom route tables. So in previous videos, we've talked about having blue spokes, red spokes, some traffic going through the firewall, some traffic not going through the firewall, and the various propagation and association settings you need for that. I mean, check out this, say, 30-minute deep dive here on how to achieve that. So when customers thought about Virtual WAN in the past, custom route tables were synonymous with the idea of Virtual WAN. But when you want to use the benefits of routing intent, one of the current caveats you run into, which I want to call out now because it's a learning which you want to sort of come across sooner rather than later. Inside the consideration section here of the routing intent document, you can see here, routing intent can only be configured on hubs where there are no custom route tables. So you actually can't even turn on routing intent if you have custom route tables configured like blue and red and various propagation settings. So what does that mean? Well, effectively, we can't realize at the same time the concept of red and blue custom route tables on hubs, as well as getting all the benefits of all these additional orange flows enabled by routing intent. And some customers want the best of both worlds. Some customers want to have mainly the inter-region flows via firewalls, but they also would like to retain an element of some traffic going through the firewall and some traffic not. And there are some topologies that unlock that for us. And that's what I'd like to talk about on this video. So first of all, let's think about one topology that is possible with routing intent. And that's the ability to have some hubs running Azure Firewall and some hubs not. So in this diagram here, I've got a hub in West Europe, which has got Azure Firewall inside of it, Express Route Gateway, Express Route Circuits, etc. And a spoke over here with a virtual machine inside. This hub here has got routing intent enabled. And all of these flows work fine, sort of spoke to on-prem via firewall. If I've got other spokes here, spoke to spoke through the firewall works. Now I've got another region over here, North Europe, and this hub hasn't got a firewall inside of it. So we can't enable routing intent on this hub because that doesn't make any sense, right? Routing intent's all about sending traffic to a centralized firewall. So if your hub doesn't have a firewall, well, you can't enable routing intent. We've got a combination here of secured hubs with routing intent turned on and unsecured hubs, so sort of traditional hubs. So maybe this is happening because of a migration, or you just have two separate requirements in different regions. So the first thing to understand is this is definitely possible. This is a flow that is supported. So we can have a virtual machine here talking to a virtual machine here, and traffic would go through the firewall here, across hub to hub, to the spoke, and it would respond and go sort of through the virtual hub router on this virtual WAN, but through the firewall on this virtual WAN hub, and back to the VM. One thing to call out here is, for this topology to work, is probably you're already running this setting, but if you can't get it working, just double check. On this VNet connection here, and any VNet connections of your attached spokes on the normal non-secured hub, you need to be propagating to the default route table of the routing intent enabled hub. And you can do that one of two ways, right? You can specify that you're going to propagate to the hub directly, or you can propagate to the default label. And because you're using the default route table over here, this will suck in any routes that are propagating to that label. Okay, so we understand that this topology is possible. And now knowing that, we can use this knowledge to perhaps realize what I talked about earlier, some of the benefits of routing intent, but also having some flows through the firewall and some flows not. And we can do that by creating a topology like this. So these hubs now, rather than being in different regions, they're both in the same region. So I've got a hub in West Europe. Maybe consider this my normal hub where I connect all of my spokes. Let's call them red spokes here. So red to red here goes through the firewall, red to on-prem through the firewall. But let's say I get a new requirement from the business, and it's, hey, I've got these new type of spokes. They're going to be very high throughput, and I've got a very fixed security requirement. Maybe it's a backup appliance or some sort of data stream, and I don't want them to go through the firewall. I don't want to have to maintain the security policy config. I don't need to have any sort of advanced layer 7 inspection on that traffic, and I don't want to pay the throughput charges of Azure Firewall. I don't want to run the risk of saturating my Azure Firewall and having to scale up my firewall for all of my red traffic if my blue traffic was to swamp the firewall. And if I want to send traffic from blue to on-prem, I don't want to go through the firewall either. Could I have the best of both worlds? Could I have my blue traffic doing that, just using the hub router, and have kind of all the rest of my red world going through the firewall? So this is where we can use the concept of having multiple hubs, but now we're still inside of the same parent level virtual WAN, but both of these hubs are inside of the same region. And you can see what that gives us is the ability for blue to blue to have its own dedicated hub here, going direct, and the thing that's facilitating this traffic is the virtual hub router in the middle of the virtual WAN hub. Goes up to 50 gigabits per second. Check out some of the previous videos on the scaling behavior there. We get our own dedicated express route gateway, which is going to give us dedicated bandwidth to on-prem. So if this is a backup appliance or a heavy data workload, maybe you've got private endpoint here going off to a storage account, or it's just a big juicy virtual machine. There's benefits here for isolation, both in terms of inside the cloud and back to on-prem. One of the things, of course, which is apparent on the diagram is that we have two hubs, and well, that means we pay twice for the hub, we pay twice for the gateway. So there are some cost implications here, but that's the nature of cloud design, right? You have to draw the line somewhere between your requirements of, you want more separation, you want more isolation, maybe you pay for more components. But that's fairly standard decision making. And if we want to go from red to blue, maybe most of your flows stay inside of red, most of your flows stay inside of blue. Well, this is supported, right? As we've shown before, if we have a data workload that needs to be accessed by a normal red VM, well, traffic will flow this way. And one of the things that we can have a look at is inside of the virtual WAN hubs, you have the ability to tune the hub routing preference. By default, traffic will prefer express route if the route is available, but you can change that to be AS path, and that's something I've done on both of these hubs. That way I ensure my traffic, when it goes red to blue, it stays on the virtual WAN hub to hub path, rather than bouncing out of the region down to my circuit and hairpinning this way. That's always something we want to avoid if possible. So now we understand the potential value of a design like this. And you can also imagine this design, if you had 4 regions globally, you could have 8 hubs globally. And that's one of the benefits of vWAN, of course, is 8 hubs would normally represent 8 squared VNet peers. Well, there's a default global mesh with vWAN and default any-to-any connectivity. But so now we understand the benefits of, we've got routing intent turned on. We could have this inter-region flow going off to 2 hubs in North Europe. But the dual hub design in a single region can give us the custom routing benefits, or kind of equivalent custom routing, because I'm not using custom route tables in vWAN. I'm kind of using separate vWAN hubs to give me pseudo custom routing. But let's switch now to the portal, and I'll show you what the config looks like. I'll show you some of the effective routes, and we can get into some of the traffic flow verification. Okay, let's take a look at some of the effective routes on the virtual machines, because that's the best way to sort of visualize and think about how traffic would actually be routed from spoke to spoke. So we'll go in order here of left to right. So I'm looking on spoke 2 at the moment. This is the VM here with 10.5.0.4 as the IP address. So let's see how this VM sees the reachability to the 10.4 range. Well, we can see here in the effective routes, if I find 10.4, the 10.4/16, which is the range of this other spoke, next hop is virtual network gateway with this strange public IP. And what that actually means is the next hop is the virtual hub router of the blue virtual WAN hub. And that IP address is some IP address that is under the covers in Azure, not actually a public IP. It just represents the next hop is the virtual hub router. So we know that traffic is going to go to the virtual hub router, and then the virtual hub router will go, oh, okay, via VNet peer in, forward it straight away. There's no firewall here. How does this blue 2 spoke see a spoke in the other region? Maybe this one, 172.16. We find it here, 172.16, same next hop. It's going to the virtual hub router. So it goes to the virtual hub router, and then the virtual hub router forwards it across the hub-to-hub connection. What about on-prem? Well, down here is a 192.168.2 range, which you can see here. It still shows as virtual network gateway as the next hop. Actually, this IP address here is different because it's express route. So I'm forwarding it out directly via the express route path, goes down to the circuit, goes to on-prem. Okay, everything looks nice there. I won't check the other blue spoke because it'll look exactly the same, but in the opposite direction. Let's jump over to a red VM. That's where things will look a bit different. So I'm on red 2 now. How does red 2 see the 172.16 range? Well, it doesn't, right? It doesn't see the specific spoke range. Why is that? Well, we know how does vWAN implement reachability to a firewall. It makes sure that the VNets propagate to none, which means the reachability is not shared with connections in the default table. So this spoke here, red 2, has no awareness of this spoke directly in terms of its specificity of its address space. The best matching route it has is one of the summary routes here. So the 172.16/12, and the next hop is this 240.132 address, which you can see is part of the hub address space, which is actually the Azure firewall internal interface. So this spoke says, okay, my best route to this spoke, go to the Azure firewall. Azure firewall has to allow or deny the traffic, then it drops it on the wire, goes across freenet peering to the spoke. What about how does spoke 2 see the world of 10.4? Well, again, if we look down the routes here, there is no 10.4 range. So the 10.4 address best matches this supernet here, which again goes to Azure firewall. What about on-prem? So 192.168.2, I don't see that route directly. Best match is this one here. Every piece of traffic from this spoke will go to the firewall, no matter where it's going to. For private traffic, you can see my internet route is still direct internet because my routing intent policies for internet haven't been modified to include the firewall. So you can see the different behavior here, and you can see how that could be used to realize what we talked about earlier. Red to red through a firewall, blue to blue not through a firewall, in the cloud or to on-prem. I'll also show you what the hub config looks like. So let's start with the red hub, my first and let's say main West Europe hub. You can see it's the secured hub because of that red icon there. If I look at my routing intent config, you can see that it's turned on for a start, and I'm sending private traffic to Azure Firewall. I haven't modified the private traffic prefixes because I'm only using RFC 1918 address space. The only time you would modify this is if you were having public IPs on VNets or on-prem somewhere in your network, or if you wanted more granular advertisement of these supernet ranges back to on-prem, if you're doing ER to ER with routing intent. But check out some of the previous videos on routing intent with Azure VMware Solutions to go deeper on that. The route tables look as you would expect, so no custom routing. Here on my red hub, I've got everything associated with the default and everything propagating to none. As we said, that's how we achieve the force routing to the firewall. We can also verify the path a little bit further. So once these spokes have sent the traffic to Azure Firewall, you can actually go into effective routes here of this routing intent enabled hub and check the effective routes from the point of view of the Azure Firewall itself. If we look down here at the effective routes, we can see, for example, that the on-prem range is learnt via express route, which we would expect, but the ranges from the other region, 10.5, 10.4, are known via remote hub, which effectively is hub to hub. So before we verified traffic was going to the firewall, now we've just verified that the firewall will forward traffic this way, and it will forward traffic this way, and it will forward traffic to the other hub across the hub-to-hub connection, not via express route or any other means. And that's because we set the hub routing preference as AS path, which we can have a look at here. You can see on the blade for the overarching hub, and we did that by editing the virtual hub, changing the hub routing preference from the default there. Similarly, we can verify the world from the other hub. So if we go back to our main virtual WAN tab, we can see again that my hub routing preference is AS path, so I change that, and then we can look at effective routes. This time I've got no Azure Firewall, so I'm effectively checking the effective routes of the default route table from the perspective of the virtual hub router. And again, we can verify the effective routes, and I'm going to download the default route table here. This hub's been used for some of the testing, so there's lots of routes here. And these are the routes that we were looking at before. So on-prem, via express route, local routes via VNet connection, and then remote spoke via remote hub. So again, via hub to hub. So we verified this, and we verified that traffic going red to blue goes back to the other hub through the firewall. Okay, thanks for watching. So just to summarize what we talked about, this topology here we're looking at with multiple hubs in the same region. If we scale this out to multiple regions, you get all the benefits of routing intent. So this easy one-click spoke to firewall to other region, firewall to spoke, whilst also retaining the ability to have some element of traffic bypassing the firewall if you have this requirement for different types of workloads. Well, thanks for watching. I'll catch you soon.